Alright, tonight's episode with Physics with Mr. C. What we're doing is we're transitioning into a new way of thinking about motion. So what we've done the whole year so far is talk about how do things move. So we looked at things like how fast is something moving, how far did it go, how long did it take to get there, and then how much did it accelerate. We're switching gears here to why do things move? This is what we're focusing on for this unit. We know that things can move, but we haven't really learned why they even do that in the first place. So here we go. I'm going to talk about holding a rock up in the air. So that's me holding a rock in the air. And then if I let it go, what happens? Obviously it's going to fall. The question is, why does it fall? Well, the reason is, well, there's a force of gravity on it. Anything that pushes or pulls on another thing is called a force. So this force of gravity here, by the Earth, is what's pulling the rock down. Okay, so the force of gravity is on the rock, and the person causing it is the Earth. So if that is the force that's acting on it, then it's going to fall down. Okay, you guys know this. Let's look at some other examples of why things move, alright? And the forces that act on them. Let's say I've got a huge box and a rope attached to that box, and I'm trying to pull it to the right. Well, in order for that thing to change its position from being there to somewhere else, I have to apply some force. Okay? Let's talk about all the forces that are acting on this box. So, if this is a big heavy box, then that means the Earth is pulling down on it with some gravity. The floor is pushing back on the box to keep it from falling through the floor. There's going to be some friction acting on the box because it's going to be really hard to move. And then obviously the last one is it's me. I'm pulling on the box. So I'm going to redraw this on the next page so that you can see more clearly what's happening. Alright, so there are four forces that we have. We have our gravity pointing down, we have our friction going to the left, we have the normal force pushing up, and we are pulling it to the right. So all four of those forces are acting on the box. I'm going to draw these two lines here to show that they are the same. We'll talk more tomorrow about why that's true for those two cases. And then those two are the same. So let's look at the gravity and the normal force here. So let's look at gravity and then normal force. If they are pushing and pulling on the box the same amount, then that means that box isn't going to move up or down at all. If we're looking at our pull and the friction, you'll see why later on in this unit, but if those two things are the same, then that means this box isn't going to, it either A, will not move at all, or B, it won't accelerate. More on that in the future, but for now, just getting you used to drawing these things. Let's do another thing here. Let's talk about kinds of forces that you'll see in this class. The most common one you'll see is gravity. Anytime an object exists at all, then gravity is affecting it. So a cup sitting on your table, your notebook sitting on the table, you sitting in the chair itself, anything that's on the Earth, anywhere, is going to feel the force of gravity by the Earth. Another common one you'll hear, and you probably know what this is friction. So rubbing your hands together, you feel a little bit of resistance there. If you are in your car, and hopefully you're not doing this, but if you're in your car going really fast, you slam on the brakes to where your tires lock up, and you start skidding across the road, then the thing that's stopping you is the force of friction on the tires. So that's what's slowing you down. Another one is tension. So anytime there's a rope involved, a string, a rope, a spring, that is pulling on something. So if you're let's see, let's say, for example, the lights that are in our classroom, they're held up by some cables, and those cables are exerting some tension forces on the light to keep it from falling down. And then in general, any force that is just applied to anything, so if I'm pushing on a table, if I'm picking up something, just a general idea of any force is just a force applied to something. So pushing a table, picking up a box, flinging something across the room, etc. This last one that you'll see often is one that you may not be familiar with, and it's called the normal force. All this means is it's normal to a surface. And in math, what that means is it's perpendicular. So let's draw a box. So we've got a box, and it's sitting on the floor, and if that was our only force right there, so if there was nothing on the floor pushing back, then that means what would happen is the box would go through the floor. We know that's not true. So what we do is we say, okay, there must be another force keeping it from going through the floor. Well, that thing is called the normal force. That is what is balancing out the forces here. So those two things are equal. Alright, well, hopefully these examples help make sense of the reading that I assigned you. It is very in-depth and long. We'll have more practice in the future of what to do with trigonometry, but for now, we're going to focus on everything that's straight up and down and straight left and right. See you tomorrow.